Hello algebra students, please find your 8-4 slope-intercept form of a linear equation notes template, and I'm going to ask you to go ahead and do the warm-up questions to find the slope of the line through the given points 1, 2 and -3, -4, and the slope of the line y equals -2x plus 6. These are from past chapter 8 notes, so go ahead and try these for me. So to start off, we're going to look at the slope formula of a line, taking y2 minus y1 over x2 minus x1 and plugging in what we know. I counted the ordered pair -3, -4 as my second ordered pair and 1, 2 as my first ordered pair. I showed you my plug-in, -4 minus 2 over -3 minus 1, which simplifies to -6 over -4 for a final slope of 3/2. For the second equation, we have to find the slope of the line. It's already in y equals mx plus b form, so the coefficient in front of the x term is going to be our slope. That coefficient is -2, so our slope is -2, or you may want to get in the habit of writing integers over a denominator of 1. -2 over 1. Moving on to the 8-4 notes, we're going to take a look at some reflections on section 8-2. 8-2, you learned about linear equations being an equation whose graph is a line. So you're going to fill that in the blanks. From the equation of a line, you can find two things. You can find the slope. So you can find the slope, which we symbolize with a lowercase m, and you can find the point where the line crosses the y-axis. We call that the y-intercept. And I just made a note, we use the variable a lowercase b to represent the y-intercept. In the box on the first page, we're going to look at the rules in algebraic terms. It says for every real number m, the graph of the equation, and we're going to fill in y equals m times x, is the line that has a slope of m and passes through the origin. That is really because there's no plus something on the end. So don't write this, but I'm going to show you. There's no plus something. If there was, it would be 0, which would mean the y-intercept, which is b, is 0, which is the origin. And moving on, taking a look at that a little bit further, for all real numbers m and b, the graph of the equation y equals mx plus b is the line whose slope is m and whose y-intercept is b. This is kind of the recipe card that we're going to use for this section, and you're going to find that this is going to be very helpful in further years of math. So y equals mx plus b is something that we want you to get used to. This is called the slope-intercept form, and it's also called function form. So the work is really easy when you're looking at an equation like we are in example 1. In example 1, we're asked to find two things, the slope and the y-intercept of the equation y equals 3 over 5x plus 2. It's already solved for y. Y is alone on the left side, which you might remember from further earlier on in chapter 8 when we manipulated formulas to get y alone. So that's a skill that you should have by now. Now when y is alone on the left side, we're looking at this recipe, y equals mx plus b. The two things we can find from this is the coefficient in front of x is your slope, and whatever's being added to your x term, the constant, is your y-intercept, and we sometimes abbreviate that as y-int. So if you look at this equation, the two things that you need to find are already found for you. The slope is 3/5, and the y-intercept is 2. So we're just going to write that out. Slope, which is abbreviated as lowercase m, is 3 over 5. Some people might be tempted to give that to me in a decimal form, but slope, it's really helpful for slope to be in fraction form. The y-intercept, which is abbreviated as a lowercase b, is 2 for this equation. and that's just because it is the constant that is being added to our x term. Take a look at the your turn and see if you can identify the two things I'm asking for, the slope and the y-intercept. So your slope for this equation is -2, or you could also write that as -2 over 1. And your y-intercept, which is your b value, is 1/2. So part of the reason that I really think you're going to like slope-intercept form of an equation is I can look at the equation in this form right now and I can plot it. By only plotting 2 points, I don't have to build a table, I don't have to plug in 0 and find the intercepts, and I don't have to do any further calculations from there. So what I want you to do is I want you to write the following 3 steps in your notes. These are the steps you're going to take, but like I said, your work is so short and you don't have to show any calculations that you don't really have any writing other than on the graph. So you can take up the entire workspace, for example, too. Okay, so go ahead and write those 3 steps down for me. The first step is we are going to graph the y-intercept. So you're going to look at the value that is the constant that's being added to the x term, and that's -7. So what I'm going to do is I'm going to go down to my graph, and I need to be very cautious because that is a minus sign. It stays with the 7, and it makes it a -7. So I'm going to go ahead and go to the y-axis because it's a y-intercept, and I'm going to graph a dot at -7 right on the axis. So right about there. Step 2 says that you're going to use your slope to find your second point. Remember, slope represents rise over run, which means change in y over change in x. So if you look at your slope for this problem, you've got -3 over 4, which means you're going to go down 3 units and then up, to the right 4. And I'm getting that because the numerator is the y. Y can represent up or down. It's a -3, so I'm going to go down 3. And our denominator is x. It's positive, so you're going to go to the right 4. Some of you might be saying, well, could I put the negative on the denominator and make it 3 over -4, which would mean that you would go up 3 and to the left 4, and the answer is yes, you can do that. What you can't do is you can't make both -3 and -4 in the fraction, because a negative over a negative reduces to a positive, and then you're not actually plotting a negative slope. So we're going to go to the graph. You're going to start always at your y-intercept. Our y-intercept was down 7 units on the y-axis. From that point, so you're going to put your pencil on that point, you're going to count down 3 more blocks and to the right 4. So if I count down, I go 1, 2, 3, I'm ending up at -10, and to the right 4, and then my dot is going to end up somewhere right about there. So we did step 1, we graphed the y-intercept. It was -7 on the y-axis. We used the slope to find a second ordered pair. What you don't want to confuse that with is the numerator comma denominator as an ordered pair. It's directions from your y-intercept. It's not an ordered pair itself. And then we're going to connect those 2 ordered pairs that we just plotted with a line. And I did make a note that you don't want to forget arrows, because this line is continuing in both directions forever, which means those 2 dots that we just plotted are not necessarily the only 2 solutions. A really good habit to get into, and I'm going to undo my line just for a second, is to also keep going with the dots. You could go down 3 more from your new ordered pair and to the right 4 more, and you're going to end up with a dot somewhere about here, I'm estimating, and then draw your line. And you can also do the reverse. You could go up 3 and to the left 4, like we talked about if you made the denominator negative. So that would end up at 1, 2, 3. That would end up about here. So you see I can make an infinite number of dots along this line. And when I connect them, I want you to understand that we're not saying these are the only solutions on this line. There are an infinite number of solutions. Any dot along this line that I drew and any that are not drawn, the infinite number are the solutions. And yours, of course, will look prettier because it'll be straighter of a line. I know that the next example is called a your turn, but I'm going to actually guide you through that because I think it's important. When we look at the equation we're given it not in slope-intercept form. We actually have this in standard form, x plus 2y equals 6. So we need to first transform that equation into function form and get the y alone on the left side in order to be able to find the slope and y-intercept. So we're starting with x plus 2y equals 6. And if you think back to, I believe it was your 8-1 notes, we transformed equations by doing two things. We first moved the x term to the right side of the equal sign, and I'm going to pretend this is a 1x. So I'm going to subtract 1x from both sides, and I'm writing it to the side so I don't accidentally take 6 minus 1x, which I can't do because they're not like terms. These cancel out, 2y drops down, 6 plus negative 1x. You could also have 6 minus 1x. Then your second step is always to get rid of the coefficient in front of y. It's a 2, so you're going to divide all three terms by 2. That gives me y equals 6 divided by 2 gives me 3. And this is where some students get confused. This is actually a negative 1/2 x. The slope is going to be negative 1/2. You don't want to make that a decimal because we're going to be plotting it in a second. I'm going to also use commutative of addition to rearrange my terms. And the reason I want to do that, and we didn't really say it until today, is because if you think back to the formula, y equals mx plus b, we always have the x term first. So that's why we recommended that you move the x term to the first position after the equal sign. Now what we're going to do is we're going to look at that new equation. I'm going to get this out of the way first. And we're going to identify the slope and the y-intercept. Slope is your negative 1/2. It's right in front of your x. Y-intercept is a positive 3. That's your b value. So thinking about the 3 steps that we wrote for example 1, you're going to first plot the y-intercept. So go ahead and do that. So I've just plotted my y-intercept of positive 3. To do that, I'm going to the y-axis and making a dot at 3. Next, I'm going to use my slope. Starting at the y-intercept, I'm going to use my slope of negative 1/2 to count out where I'm going to go. So looking at what the slope tells me, the slope is a negative 1/2. Remember, the numerator of your slope is y. So you're going to go down 1 unit and to the right 2. So put your pencil on your y-intercept dot of 3, and you're going to count out with me down 1 unit, landing at 2, and to the right 2. So your new dot should be at the ordered pair 2, 2. Now you're going to use your pencil, and you're going to connect those 2 dots. But before we do that, let's go ahead and put some more points on that line. We can then start at the new point, the bottom point, and go down 1 more, and to the right 2 more. Down 1 more, to the right 2. And see how I could keep doing this infinitely? I'm not going to because I don't have enough paper. But when you connect those points, they form a line. And my line is a little too thick. When you connect those points, they form a line of all the different solutions of that graph. Looking at some food for thought kind of at the end of that example, If we see two lines on a graph that are parallel lines I know that you've heard discussed are two lines that go forever in the same direction but never meet, never intersect, never have an intersection point. That is because they're the same steepness, which means that they both share the same slope. So no matter how far you draw those parallel lines, they're never going to meet because they're exactly the same steepness. So the distance between them is always the same, which means they're never getting closer or further apart. So that's just the relationship between parallel lines that you're going to need to understand. Because for the next one, we're going to take a look at a parallel line situation. If you take a look at example 3, I'm asking you to write an equation of a line where the y-intercept is 10 and it's parallel to the graph of y equals 3x minus 2. So a couple different things here. The first one that's jumping out at me is let's go ahead and talk about the two things we need to write an equation. We need our m value, our slope, and we need our b value, our y-intercept. Let's fill in the easy one because they tell us exactly what b should be. B should be 10 because they want a y-intercept of 10. Then you want to think about parallel lines. We just talked about how they have the same slope. So basically you need to go to this equation and you need to find the slope of that equation. The slope is 3. So if 10 is the b value and m is 3, our equation we would write here would be y equals 3x plus 10. And you're all done. Make sure you bring any questions or concerns to your math teacher the next time you see them for class.